the same reaction from that other one, so which we haven't really worked with before. So I'm just gonna write out what it is. I'm writing this big circle instead of a phenyl group just because it'll eat up a whole bunch of time to write it that way. Okay, so here we go. Now we have uh, sodium nitrite and acid, and we're using hydrogen borofluoride, whatever this thing is. Okay, right. So this thing over here is to make it a diazonium, right? And this one over here is to add fluorine. So what we wind up getting is in the para positions. Whoops, well, that's a bad circle. Here we go. Two fluorines. Okay. Um, oh, there have been questions in the chat. Whoops. Yeah. Uh, oh, sorry. Didn't have these up. Okay. Yeah. Okay, so Mariana asked when do we know how to use the Stork reaction in a retrosynthesis? So mainly this is sorry. Yeah, I'm just gonna address some of these questions because I like totally didn't see them earlier. Sorry about that. Uh, Before the Stork reaction, you use it primarily if there's like a large chance that you wind up forming. Well, so the Stork reaction is more like selective about which parts will react than, let's say, making a straight up enolate. So let's see. There was one good reaction in the book which I liked and I thought was good. Which let me try to find again. Um, there was one particular problem that used the Stork reaction, and I thought it was a good one. So it was. Um, yeah, here we go. Problem 2253 in the book is a Stork reaction. And so the reason you use a Stork reaction there is because you know which yeah, it winds up being because you know like where the enolate or not the enolate, but you know where the nucleophile is going to be. Uh, Whereas if you make an enolate, sometimes it'll be tougher to know. The Stork reaction doesn't show up way too much. I mean, there's a few times where like it'll be better to use than other things, but it's I think usually just gonna be whenever there's like uncertainty about what's gonna be uh, your nucleophile. Okay, let's see. David gave an alternate. Yeah. Okay. Yeah. Yeah. Mariana. So I recommend. Yeah. Problem 2253 is a good one to try out because like that's one where uh, it specifically suggests that you use a stork. Um, yeah. But usually, uh, well, the thing with making enamines is that you can go back and forth, like you really easily go back and forth between like enamine and having a ketone. So in that sense, like it's that's like something that you can do relatively easily, going back and forth between them. So that's good at least. Okay. Let's see. David suggested an alternate synthesis, which looks like it was right. So yeah, that would be like a good alternative. Um, yeah. Okay. All right. Let's just wrap up what we've got going on here. Okay. C3 doesn't have anything going on. Yeah, maybe I cut out part of the rest of this uh, problem. Maybe it's possible. Let's see what we have going on. Nope, this is the whole thing. All right, let's see what should wind up happening. So if we take this stuff uh, plus, all right, yeah. Uh, don't know what they're going on with over in these three boxes. This is like I don't know how they expect you to know what you're supposed to do without actually seeing what the product is. Uh, what? Well, I'll tell you what the problem expected, which there's no way that you would just like figure this out. Uh, so if you use this thing, except it's para substituted, I guess, uh, then
That makes sense.
They gave it to us in
You
the
just made
worksheet,
up
but
two different products.
you cut it up.
oh hey, okay, thank you.
No problem.
Yeah. Uh, yeah. So now if you add, okay, all right, yeah. Whoops, I totally missed that. I shouldn't have put that out then. Okay, so now if you add this ethylene glycol, and it's in acidic conditions, then you make uh, this thing, which is called anybody?
Acetal.
Yeah, it's an acetal. Uh, okay, so now you can do NBS, so you can brominate, okay, which will go on that end because the other end doesn't have anything going on. It's got no hydrogens to get rid of. Okay, now then you make a Grignard and then carboxylate with CO2 and then do an acid workup. Okay, and that acid workup will remove the acetal. Remove. Okay, here we go. Acetal. Okay, so we'll turn back into what it was. There we go. This thing is para, and it'll be no. It'll actually have an extra carbon, right? Because we added it by CO2. Yeah, there we go. Okay, now is everyone on board with this now? Now that I totally missed what they were going for with that first step.
Yep, I think we're good.
Okay. All right, and let's open up here we go. Oh yeah, nice and short. Okay. So D1 came from somewhere, which let's see where this came from in the grand scheme of things. So
It
let's
didn't
see,
come
where
from
does this?
anywhere. It's not attached to anything.
Oh, so well, okay. Yeah. Oh, okay. So it is up here. There's a phenyl ring and two aldehydes. Oh, I'm running out of room. Ph. And the same thing over on this end. So we did have this up here. Okay. And so we're reducing it. So we have two anhydrides. Oh, I called them aldehydes earlier. Oops. We have two anhydrides and we're reducing both of them. So from one side, it'll get you that. And from the other side, it'll get you a ring with two two alcohols on it. Maybe I'll actually draw the ring this time. Okay, so two alcohols like that. Okay. I guess we're not actually using that anyway. So give it SOCl2 now, which is this is like not a less common use of SOCl2, but if you remember from Orgo 1, what it does here is that it replaces an alcohol with a chlorine. All right. Next step, we'll worry about this direction in a minute. So next step, we take sodium cyanide and do it in DMSO. So those are like really classic SN2 conditions. So, all right, we'll just do SN2. And now lithium aluminum hydride onto that nitrile, which will reduce the nitrile all the way to this guy. Okay. And if we're working backwards, then uh, you could have sodium nitrite there and heat it. So let's see. We had if we're going backwards, then we've got uh, N3 and yeah, let's see. There will be a carbonyl here if we were doing it this way. Okay. So this would go backwards and would be this thing, and you would go back doing SOCl2, and it would go back to being an acid. Okay. Uh, I don't think we've seen this very much. This seems like not something that we've talked about very much, so I wouldn't worry about it way too much. Okay. And then the very last two here, we have this chlorine and we have this thing over here, which is a good nucleophile. Does anybody remember what this reaction is called? This thing here should give it away if anybody remembers this one, but it's mentioned very briefly.
Gabriel.
Yeah, so this is the Gabriel synthesis, okay? And this thing is super big. Okay. Yeah, so it's, this whole thing. Okay. And then you add hydrazine, this guy, and basically it's just a long and complicated way of making a primary amine. Okay. So here we go. Yeah, it makes a primary amine, NH2. Okay. And you get plus this other extra product hanging off the end. Okay. Are there any remaining questions? Especially if you have like questions about the exam or something. I mean, I have no clue what your exam will be like either, because if this is like nobody knows what your exam will be like. But if you have any like just general questions, I'd be happy to try to help. So, I'll upload everything to Canvas and my website as normal. Usual stuff. Thank you. You're welcome. Thank you for coming. Hope I could help in some amount. I didn't like this roadmap too much. It included a bunch of stuff that like we didn't really talk about very much, but maybe you liked it. Oh, for some people who are still here, I put a sign-in thing on like the folder from like my on like the website thing. I completely forgot about this last time too. If you do sign, like if it would be helpful if you just like put your pen ID there, like how I normally have people do, like just write your pen ID on the thing. It's like a spreadsheet thing. Just like if you sign in, that would be nice to have people know that people came officially. But that's all. That you could do that on your own time. Um, Thank you for coming. All right. Does anybody have any questions they want to ask?
Yeah, could you put your email in the chat again?
Yes, of
Or not
course
your
I
email.
can.
Sorry, your website.
Oh, let me put both.
Yeah, I guess I don't have your email either.
I went to go sign in just now, and I think it's on view only right now in the spreadsheet.
Oh, oh man. All right.
Sorry about
Yeah, how
that.
about I change that? Let's see. You can't. Oh yeah, yeah. Edit. There we go. Why? That's like. Yeah, there we go. Okay, it can be edited now. Thank you for letting me know. Um, yeah, just write your pen ID. It helps me out. Keep track of how many people show up. Okay. Any other questions?
Gold water.
Thank you.
You deserve it.
Oh boy. Uh, well, my organic chemistry can be shady sometimes, so you know, it's interesting. Thank you. Very nice. Yeah. Any questions? No? Okay, I'm gonna sign off. So, I'll stop recording. Okay, bye guys.